It's really good to have you here today, and thank you for coming. So what we will do today is we'll have an introduction to LaTeX, and this workshop is designed for you as third and fourth year student on at least the basic things in LaTeX. Can you see my screen?
Yes.
Good. So what we will see today, first of all, we want to say, what is LaTeX? What is this? What we are going to do with LaTeX, and what can we do with LaTeX, and why are we going to use LaTeX for our mathematics writing? Next, we will learn about something we call it the editor and the text distribution. And then we will see how the LaTeX document is divided into body parts, which we call it the document part, and preamble. Later, we will see some symbols and how easily we can write them using LaTeX. And then we will talk about the mathematical formula like f of x equal x squared plus 2x plus 1. And then we will see something very important and powerful called the environment in LaTeX. So this is the table of content, and let's go ahead and see what is first thing first is what is LaTeX. First of all, LaTeX is LATEX, and how we pronounce it, we say LaTeX. Sometimes we just call it in one sound like LaTeX, but we will never say LaTeX. So this X is not pronounced. Either you pronounce it as a kha or as a t. So it's LaTeX. Okay, now we know how to pronounce the word. We know LaTeX. What shall we do with LaTeX? LaTeX is a mathematics typesetting program. If I ask you now to write a letter or to write an English essay, first of all, you will go to Microsoft Word. Is that correct? If you go to Microsoft Word, you open a new document. Here you can write a letter to someone, my teacher. Is that correct? And then you start typing things and so forth. In mathematics, if I ask you to write for me equations and integrals and solution for an assignment or a solution for an exam, where you will write them, you will write them using LaTeX. So LaTeX is a typesetting program which is designed for mathematics, and it's the standard one. As the Microsoft Word is now the standard one in every computer, LaTeX should be the standard one for any mathematics writing. Now, a bit of a history. First of all, LaTeX was introduced in 1978. 20 years before you're even born. Some scientist called Donald Knuth from Stanford University, he created something called TeX, T-E-X. Okay, and that was a very basic because the computers was basic, but that was the origin. Later on, someone with the name Leslie Lambert, he created the LaTeX, which he added the LA. So TEX, the first part was due to Donald Knuth, and then Lambert, he added the LA, and now what we have is the LaTeX, which is much friendly version of TeX, and I will tell you why we call it friendly version. And recently, the one that we use is called LaTeX 2 Epsilon, which is now the standard one, is called LaTeX 2 Epsilon. And I will talk about it later, but that's a bit of a history. So it's kind of 3 stages for the LaTeX. It started with TeX, and then LaTeX, and then LaTeX 2 Epsilon. Do you have any questions before we continue? Do you have any question? Okay. Before we continue, I'm sure you have already seen in your computer science course, maybe ITCS 113 or 113. Yeah. How do you write something in Java? Was it Java the one that you have seen in your computer science course?
Yes, Java.
Do you remember how you code in Java? Can someone tell me? How do you code? What do you do? Zahra, can you tell me?
You just code, you like use the language of Java.
The language. And then there is something called compiler. Is that correct?
Yes.
In LaTeX, we have the same thing. We have the code, and then there is something, we call it the distribution, which will kind of compile the code, and he will give you the PDF file you want to see. So where are we going to write the code? Or we call it the markup. We do it in a file in the editor, and we save the file as .tex. So here we write the code in that file, which is .tex, and the distribution is like the compiler, which will read the file, will read the code, and it will convert it to PDF, for example, or DVI, which is device independent, or PS, or any other format as you want. It's a translator or a compiler. So we have two things to keep in mind. If we want to install LaTeX in our computer, we have to install an editor where I can write the code, and I need to install distribution, which will read the code as like the compiler. So it's kind of the same idea as in Java. Do you have questions before we move on to the next slide? Question? Good. Next. How are we going to write the code? Again, it's similar to Java, and I will let you by yourself reflect on the similarity, but in LaTeX, your document has two parts. You have to write the preamble, and you have to write the document. So this is how it will look. You will have something in the top, okay, full of codes. It's called the preamble. And then your code itself will be in the document parts. So let's see which one has what, but this is always the structure. At the top, you have a block, we call it preamble. You will add so many things, for example, the font size, the font color, the page size, the background color, everything, you add them in the preamble. And in the document, you write whatever you want to write. For example, you write the integrals and you write the solutions and everything in the document parts. And here is the explanation. In the preamble, you tell the editor what kind of document you are making, what packages you are using, and you give your work a title, and you can write the author, and you can do some formatting. So it's the preamble is something that will happen to all the pages, to everything you write. You have to tell your LaTeX document the size of the font, the color. Are you using A4 papers or are you using A3 papers? Whether you want it to be horizontal or vertical, all those information you have to tell them in the beginning in the preamble. In this workshop, we will not focus on preamble. It's just something there and we will use it as it is. We will focus on the document part, which is the body, which is all the figures, all the equations, all the tables, all the text will be written. So we have two parts, we have the preamble and we have the documents. Do you have any questions about the difference between preamble and document? We will see it later in action, but this is mainly the general idea. Any questions? Any questions? Okay. Now, do you remember this symbol? Can you see it?
Yes.
Do you remember it, right? What is the symbol?
For integration.
For integration. Now, if you want to type it in Microsoft Word, this is very difficult because in my keyboard, I don't have it. Okay? So I need to look at it in Microsoft Word, which will take so much time. Even if you go to the help and you write integral, it's horrible to deal with it. Look, you have to write, I don't know. Look, it's not where I should write. Nothing is forward. It's not an easy thing to do. Okay, how we will do it in LaTeX? If you want this symbol, which is the integration, all you need is to write slash, and then you write int. Now, the compiler or the distribution, he will read this one, and he will produce this symbol. Same thing for this one. Do you know what's this?
For sum.
For sum. So all what you need to do is slash. Slash means you are telling the compiler to bring the symbol of the sum. Of course, those you need to memorize them, and you will memorize them with the time. Can you tell me what is this? Is this an A?
Alpha.
It's alpha. So what do you think? How do you write it? How you will write for your compiler to produce alpha?
Slash alpha.
Exactly. You cannot just write alpha because he will not understand. If you want him to produce something for you, you have to write slash. Now, how about x power 4? Look, this is very difficult to do in Microsoft Word because I want x in the base and 4 in the power. Now, in LaTeX, it is very, very easy. Okay? Believe me. All what you need to do is you have to type x, and then you have to type shift number 6, and then you have to type 4. That's all what you need to do. Now, the compiler will read this one, and he will give you x to the 4. I can do it here in Microsoft Word. But in LaTeX, it's just one line. I can type it as this one. What happened? Okay. The next one, how do you write a fraction x over y? The idea is very easy. You start with slash, and then you write frac for fraction. You open parentheses and you write the top one first and the bottom one second. Numerator with denominator. And that's it. Is that clear?
Yes.
Okay, let me just give you a quick quiz. What do you think will happen if we do this?
Three over 8.
Exactly. So what you will see, the compiler will write 3 in the top, 8 in the bottom. Is that clear? Now let me just tell you something. Can you guess what we will get if we do this? What do you think will happen here? What is our compiler will read this one?
Integration.
And then why do we have sub 1 and then 2? This will give you the integration from 1 to 2. This is how we write it. Because I want 1 to be down in the integration and 2, I want it to be in the top of the integration. So I will write it, take 1 down, take 2 up. How about this one? What is this? What's this?
Function.
Remember, what is this function?
E to the x.
E power x, because remember, this is used for the power. Thank you. So at least now you have the idea of what LaTeX is powerful for and how it will make our life easier. Okay. Now, if you want to use those formula, if you want to use those formula, you have to put them between dollar signs, because not just if you write /int, he will understand. You need to put them between $sign, and this is, we call it the inline. So here the inline. We'll see it in an example in a minute, and we'll see all of this in a minute. But I want you to tell me something here. Can you tell me the difference between the function here and the function here? Can you tell me what's the difference between the two functions? The one in blue and the one in yellow. Are they the same?
البلو بتكون مجموعة، اليلو
لا بس هل هما نفس الشيء؟ هل f of x اللي صايرة داخل السطر نفسها هذه اللي موجودة هني؟ Are they the same?
نفسها.
Okay. But which one is nicer and clearer and more beautiful?
الأصفر.
Exactly. And this is what we call it display style. Usually when we write equations, and if they are big equations, you need to write it separately in the middle of the page, because when you look at it with your eyes, it's easier for you to read it, much better if you just squeeze it between so many words before and after. Even you have to make it small and you have to put things next to each other. But here, it's like you have a space to do many things. Is that clear?
Yes.
Okay. So this is, we will call it display style. Now, before I go to the environment, let's go to do some practice. Are you ready for practice?
Yes.
Okay. Now, for practice, what we will do is, I would not download LaTeX. I will not ask you to download LaTeX because this will take time and we just want something easy. We will go to www.overleaf.com, which is this one. Why? Because if you can read it here, it is the easy to use and it is online editor. I don't need to install anything. I don't need to do compiler with editor. This is everything you need. On the left, you will write your code, and on the right, you will have your output. So I will log in. Of course, you can log in with Google. Is the easy way. And then let me do a new project. So I will just do a blank project. I will call it workshop in LaTeX. This is kind of a big folder. And the nice thing here, he's writing for me everything I need. I don't need to think about anything. He's just telling me, come here and write. So what do you want me to write first? Hello, student. It is nice to meet you. And then you just click on this button and you will see the output here. See? Here we are. It's there. Now just let me shut off those things. I don't want the titles. Okay. This is kind of a comment. When you do this, it's kind of a comment. Oh, there is an error for some reason. There is something he didn't like I did. Maybe just let me also comment this one. And now, hello student, it's nice to meet you. Okay. Now, let's write some mathematics. Give me any equation you think of.
y equal x.
No?
Y equal x.
Yeah, this is easy equation. You can write it even in Word. I want some complicated equation. Which course you have today? 311, 312, 303, 304, 341, which course? What was your favorite course today?
312.
312. So 312. And what was the topic for today?
Ring homomorphism.
Ring homomorphism. Great. So I will do a homomorphism, which we call it what? What is your homomorphism? How do you write your homomorphism? Is it F or what?
Yes, you can use F.
You use F?
Yes.
And it was from where to where, the homomorphism? From the integers to the integers? Or Zn to Zn?
You can use any two rings.
Give me two examples of any two rings you want.
Real numbers to real numbers.
Okay, so you have to write from R, and then you want to have an arrow. Is that correct?
Yes.
So the arrow, I will write /2. This is the code for the arrow, and then I will do R. Let's see. Look. Do you see it?
Yes.
This is the arrow. It is nice, it is easy. But for R, I don't want it to be R like this. I want to say this is the real number. And do you know how to write the real number? Usually we write 2 lines. It has a fancy way. Right?
صح.
Yes.
So if you want to have it a nice way, there is a code for it, special code. We call it math BB, and then you open brackets, and then math BB, you open bracket. Of course, those you will learn them by experience. You don't need to memorize them. Now look what will happen. Oh, okay. He didn't like this one. Let me just add the package. Hopefully this will, I will tell you what I did here. Okay.
I think you forgot the $sign.
No, not the sign, because I am already in display. Oh, he's very angry about me now. Okay. Oh, no. It was double H here. It's very sensitive to whatever you write. Now it should work. No? There's something he didn't like. I did something which is he didn't like. Anyway, let's just ignore the homomorphism. Any other course you have today? What's your favorite course today, other than 312?
411.
311?
411.
Oh, 411. Okay, what was the topic for today?
Homomorphism groups.
Oh, no. Enough homomorphism for today. Any other one? Okay, let's suppose you are in Calculus 1. What is your favorite topic in Calculus 1? Was the integral? So let's do integral. So I will integral from 0 to which number you want?
By.
2.
To by?
Yes.
Look how I write 2 by. I write 2, and then because I want him to give me the symbol for by, I have to write /by. Now he's really angry for me. Okay, now it's fine. You see? He will write for me the symbol by. I don't need to write it myself. I only write the code for the by, which is /by. Now, what's your function? What is like a scary function?
Tan square x.
Okay.
Tan square x.
So tan, so I have to write the code for tan, which is /tan x. And then I write the x. Look at what happened now. You see? In 1 minute, in one piece of code, I can type a whole integral. Now let me make it harder. Let me do this function. 3x squared minus x over 1 plus x squared. Now this is a fraction between two things, and he will do everything for me. Look, he did everything for me in a very nice way. I don't need to write anything. All what I need to write is the code, and he will understand the code, and he will do for me the code. And that's how we do LaTeX. Do you have any question? Do you have a question? Yes or no?
No questions.
Okay, now we want to talk about the environment. Okay. Now, suppose I'm writing to you in the exam, please solve this question, for example. Okay. Now, let's see what happened when we compile it. He wrote it in the left, right? Do you see where it is? It is in the left. Do you agree with me?
Yes.
Now, suppose I wanted to write it in the middle. Well, if you do space here, he will not understand it because he doesn't understand what you write here. You have to give him the code. He doesn't understand what you do. Look, if I compile it, he will still put it in the left. Even if you have more spaces here, he doesn't care about your spaces. He will still have it to the left. So you have to give him a code. You have to tell him. You want to tell him everything here should be in the middle. And what is the middle of a page? Is it left or right? Or let's start with the letter C. What it would be?
Center.
Center. And that's where you need environment. Environment means you will tell him begin, center, and then of course you have to tell him end center. Because environment means if you want to center something, everything here will go to the center. And it will end here. Now look at what will happen here. You see? He bring it to the center of the page. Please solve this question. Now, why do we need end center? Because whatever coming here now what happened? What do you think happened when I click compile? Group homomorphism will be where? In the center, or where do you think it will be?
Left.
Exactly, it will be in the left. You see? Because I end the centering here. I start the center, everything in the middle will be sandwiched in the center, and then I just stop, forget about center, and go back to normal. Now, what happens if I want group homomorphism to be in the center also?
انقل الأن تحت.
ننقل الان تحت. And now everything is centered. Is that clear, the idea of having something in the center?
Yes.
And that's the idea of the environment. So what is the environment? It's the environment where you add things the way you like them. You want them in the center, you can add them to the center. Now, do you remember those kind of questions? You have seen them in Calculus 1?
Calculus 2.
Calculus 2? Do you remember we have so many steps to find those integrals?
هاي التكامل بالتعويض.
Exactly. So let's try to do them. Now, if you have, and this is the most important environment, if we have an equation, it has many steps, like the integral. You do the integral, you do substitution, you do find the answer. The environment will be called align star, and this is the most important one. So let's see align star. I will do the integral from 0 to 5 of this function. 1 over 1 plus x squared dx equal. Align. Okay, he didn't like it. Let's check later. But for now, I'll just do the display, the normal one. Can somebody solve this question for me step by step? This one. I'll get back to you. Try to think about it. Let me check what's wrong with begin align.
You need the AMS math package.
AMS math. Yes, you're right. Thank you for letting me know about the AS math. I already have it here. Let me just remove this simple AMS math. Here we go. It's working now. Can you solve it for me? What should I do? What should I do?
هاي بتكون tan inverse x.
Okay, good. So this will be tan to the inverse of x, and then you substitute it from what? 0 to 5. Let's see. Is this will show up correctly? Oh yes. Is it correctly now? Is this what you will do in your calculus?
Yes.
Now what you will do next? What are you going to do next?
نعوض.
Now. So it will be tan inverse of what?
5
And then?
minus 0.
Tan inverse of 0. Okay. Now this is, so far, is it fine? We solve it. You see how quick we did it? We are very, very quick. Are we quick?
Yes.
But sometimes I don't like you to write for me equal and then equal. I want this one just for my eyes. I want all of this, the second part. I want it to start a new line. I don't want it to be in one line. Just I want to see them step by step. And how we are going to do this with the align, all what you do is having this one here. And the place where you want them to be the same, you just add ampersand. Is that clear? Is it clear now? Is it nicer?
شنو اسمها اللي حطيتها؟
نعم.
شنو حطيت لك؟ شنو اسمها؟
اللي حطيته أول شيء المكان اللي حاب أحافظ عليهم فيه خليت هذه اللي كأنها and. وخليت هذين السطرين عشان ينزل سطر جديد يعني.
تمام.
الآن I have to do the same thing. I put double slash and I put and I put equal, and then what's the final answer? I don't know if you have a calculator. Tan inverse
ال5.
antivirus. Now look how neat and how nice it is. See? And that's it. That's all what I want to say about the LaTeX. So I think for an introduction seminar, that's what I need you to do. Of course, try with Overleaf and just find a search for a nice book, and then you can do everything. It will take some time until you get used to LaTeX and how you type in LaTeX, but you quickly will be powerful in typing mathematics. So please, if you have any questions, I'll be happy to answer them. If you don't, I'll stop the recording now.